Hello everyone, and today we're doing the part number 6 of learning Rust with our rustlings. And this time we're gonna start with threads. Okay, so we already can see an error, which is something about having an explicit type of vector, but of course we should start with actually seeing the exercise itself. Okay, so this program spawns multiple threads that each run for at least 250 milliseconds, and each thread returns how much time they took to complete. The program should wait until all the spawned threads have finished and should collect the return values into a vector. C. So, what happens? I have a vector of handles, and then we have a for loop, and for loop it has it tries to spawn 10 threads, and each thread just does what it says it should do. It sleeps for 250 milliseconds. Okay. And then it returns how much time have passed. Okay. And then what should we do? We should collect the results of all threads into the results vector. Use the join handle struct, which is returned by thread spawn. Okay, and then it checks that we have 10 results, and then it prints the values in the vector, in the results vector. Okay, so we should probably read about threads, right? They give us 3 links. First one is talking about some kind of tiny philosophers. Okay. In ancient times, wealthy philanthropists endowed a college to accommodate 5 eminent philosophers. Each philosopher had a room in which they could engage in their professional activity of thinking. There was also a common dining room, furnished with a circular table surrounded by 5 chairs, each labeled by the name of the philosopher who was to sit in it. They sat anti-clockwise around the table. To the left of each philosopher there was laid golden fork, and in the center stood a large bowl of spaghetti, which was constantly replenished. A philosopher was expected to spend most of their time thinking, but when they felt hungry they went to the dining room, sat down in their own chair, picked up their own fork on their left, and plunged into the spaghetti. Such is the tangled nature of spaghetti that a second fork is required to carry it to the mouth. Philosophers therefore had also to pick up the fork on the right. When they were finished, they would put down bowls, their forks, get up from their chair, and continue thinking. Of course, a fork can be used by only one philosopher at a time. If the other philosopher wants it, they just have to wait until the fork is available again. The classic problem shows off a few different elements of concurrency. The reason is that it's actually slightly tricky to implement. A simple implementation can deadlock. For example, let's consider a simple algorithm that would solve this problem. Philosopher picks up the fork on their left, then they pick up the fork on their right, they eat, they return the forks. Now let's imagine the sequence of events. Philosopher 1 begins the algorithm. Okay. So, why can nobody eat? I see. So they just sat down and everyone picked up a fork, and there are only 5 forks. Different ways to solve this problem. We'll get to our solution in the tutorial itself. Is this the Rust language book? What's that? It's not the Rust language book. Well, okay. So we have a struct that represents philosopher, okay. And we have a method new that what it does is just create a philosopher with that name. Or we create 5 of them. Okay. Let's see, so it's just a convenience function. Here's a function eat. Okay. So on the function eat, it calls the thread sleep for 1 second. Okay. And first they run them basically in serial, right? It's pretty easy, like, to kind of understand what it's about. Put exactly this, basically, in order they were introduced to the vector. Okay, what happens next? Next they do like an iterator, and they like do a map, and they spawn a thread with a move, and they collect all that into a new vector. Okay. We'll just kind of call it a thread in a basic way. Again, nothing that aren't happened yet. Then we introduced mutex. Okay. Vector of mutex is basically now philosopher it has a left and right. Assume it's like right. So mutex is a way to control concurrency, yes. So okay, but I mean mutex is good. Okay, so each hand represents an index of the fork. So if if the fork on the in the left hand is number 1, and the fork in the right hand is going to be number 2. Basically, we have a vector. So it's a table, and a table is a struct that has a vector of mutexes. And why do we need a struct? Can we just put vector in? Can we just put a vector in like a sync? This is a sync. It's atomic. Sorry, atomic reference counter. So then what it does, just thought like clones the table, and the it function gets the reference to the table. Okay. Now it's gonna like deadlock, obviously. No, it's not gonna deadlock because I see now. We're gonna deadlock because we have mutexes, right? We introduce mutexes. Should we unlock them, by the way? Maybe we don't need to. Maybe they can just kind of disappear, right? So when you lock a fork, like any other scientist or philosopher won't be able to use it. Okay, but I'm actually kind of curious right now how like mutexes work, and they don't provide us with a link. Okay, and that's interesting. So what we need a mutex, right? Okay. This is a mutex, alright. So the mutex will block threads waiting for the lock to become available. The mutex can be created via a new constructor. Each mutex has a type parameter which represents the data that it is protected. So what do like the mutexes here protect? They protect nothing. They protect a unit type. Okay, makes sense. So the data can only be accessed through the whatever guard return from lock and try lock. Well, the data is only accessed when the mutex is locked. For mutex, this means that the lock and try lock methods return a result which indicates whether the mutex has been poisoned or not, whether it's poisoning. Where a thread panics while holding the mutex, okay. Okay, so the lock disappears when like this gets this collected. There is no garbage collection. Just so if I would use the correct language, that would mean when the how they say it, life cycle of the variable ends. It holds a locked data, so we can then unlock it again. Okay. So we got some examples now, and we should like do this, right? So we gotta collect them. Okay. Yeah. How do we collect them? So for endo and endos, I mean, if we're gonna do like that, then we just should we should do the current results push endo join unwrap. So what does unwrap does? I forgot. It's a mutex, but it's a thread, right? Should just kind of duplicate that. And I search for a thread, yes. So what can thread do? We can spawn it. It will return a join ANO. What join ANO is? You can join it, and what it is a result. What do we know about results? It's a result. Oh. No error trade. I'm just gonna unwrap for now. So we did that. I mean, we just solved that. Let's check the solution, I guess. Not like it's hard or anything. To the next one. So building on the last exercise, we want all of the threads to complete their work. But this time the spawn threads need to be in charge of updating a shared value. Job status, jobs done. So guess what happens, so we have a reference counter. And it says that atomic reference counter isn't enough if you want a mutable shared state. Okay. Mistaken action before update shared value. We must take an action. What kind of action? Is that's must take an action. Like what kind of action? So again, what can an arc do? Kind of like wait, there's something. It's atomic, right? What's the problem now? You must take an action before you update a shared value. I mean, this is like this, right? Seems so. Seems so. Isn't enough. Do they expect us to use that? Then we want to have a mutex, right? Like, where about the mutex one is one here? So it's gonna be a mutex U and this, and then we can do like that. Oh, into like, yes. It's still, I mean, okay, we're not writing goal here. Yeah, sure. So what's the issue? It's mutable. It's not declared as mutable. Oh, okay. Should work now, right? No, but because we need to print it. We need to print it, right? Oh, I guess like the easy way to do it is to just like okay, let's see the solution. I think we did it correctly. Yes, we use a mutex. And we create a new mutex. We can also do it like this, no need for a variable. I guess we're gonna just do just that. So that's a good idea, to be honest. Less typing. We don't need to access it any more than that. And it's jobs, main jobs, okay. And then just that. Okay, makes sense. Until the next exercise. So we have a key. Q. It's Q, right? Yeah. Pronunciation is always hard, guys. It's Q. We want to send TX to both the threads, but currently it's moved to the first thread. How could you solve this problem? What's TX? I mean, TX stands for exactly thread model TX. What's a TX threads? So, like, I guess one like sends, another reads. We need to check the code. So a queue, it has two vectors of unsigned 32-bit integers. And then this queue has a new method that creates a queue, okay. Then we have this sendTX function. Something. Who cares, right? And we create a channel. Okay, channel's good. And we create a new queue. Also good. And then we send text to the channel. Weird. So we have 3 threads. And then we have a received and we read from Rx. And then we sort them and then we like check. So I guess Rx stands for like reading and TX stands for, I don't know, texting. Yeah. Okay. So we want to send text to both the threads, but currently it's moved into the first thread. How could you solve this problem? So real. We have to like use them, and you probably also want to like a mutex, right, or something. But first, I wanna like read about the channels. So there's sync channel. It is like a regular channel. Which one? Which one this use? Use the channel. Create a new synchronous channel. Synchronous means good, right? But doesn't exactly means concurrent. Order BBK label. It was sent. And no send will block the calling thread. This channel has an infinite buffer, unlike sync channel. So it would mean that there's no really need to like sync it, right? Or maybe there is. So let's try the down way, then we try maybe the correct. So this is no. I want things to happen in like two times. So we need like tx1 gonna be, we need to, let's see, oh, like this. Feels kind of not organized, right? And so as for sync, I want these, right? I wanna this, and then I wanna this is good. And then for this one, I want it's gonna use this. It's gonna use this station. Elibird after the move. Variable moved due to use enclosure. Oh, we can create two of them, right? And it did work. Genius. Well, let's see the solution, I guess. Oh, you can just clone that. Wait, what are the types? So, secret channel. Okay, secret channel. Well, there are a sender and a receiver. Also sender. Okay, so we can do it the most nice way. No, probably we should have read something before. Yeah, so they mentioned Go and do not communicate by sharing memory, so share memory by communicating. channels. Yes. Okay, we create a channel. And this is all easy and nice. No problem really. But let's see what happens next. What happens next? Did you just send it? Okay. Let's see what the about clone. It's time before we create the first spawn thread, we call clone the transmitter. So give us a new transmitter we can pass to the first spawn thread. This seems to be like cleaner way to do this. Like this one should have clone, right? The clone as in this. Okay, strong reference counter. Nice, really nice. Don't need to count any reference there, do we? So we just need to do that. Go tx clone. Let's just code like what they call it. No, just done that, and we can just use this. We already need that. And we don't need atomic reference counter. And don't need that. Should change the variable name back. And change it here to a clone. It should be clone, should be really like tx cloned. Be precise. That does work. Okay, and the next one is macros. Nice, macros nice. We have 4 exercises on macros. Fix the macro. Seems we need to do a bit of reading. How much do we have left? We have only what? Okay. A bit of topics left. And I want to check out the readme and send us to the language book. So what's the difference? I think we should read this. Macros. We can use drive macros. That okay, let's just read this. It's meta programming. Okay. Line of code. Yes. Macros can work without types. Yes. And expanded by the compiler. Good. Can create a macro. Okay. So what's the issue? Check out my macro. I think we need to do like this macro export, right? Now it's all good, but we need also to use an exclamation mark. That should work. And this probably will be the answer in this macros question. Macros exercise. And there we see it. The second one. We need to fix the compiler error by moving the whole definition of this macro. I think they mean this, right? So we just need to move it. And now it works, right? The solution is gonna be pretty obvious, but just want to be sure in my skills, I want to say. So what it means that kind of the order solutions exercise number 1, we don't need an expert, and the error was because of signal that mistake by me. So just to need that, because the macro export annotation indicates that the macro should be made available whenever the crate in which the macro is defined is brought into scope. So basically it's something like, if you have a library, should we like export the macros they have. Okay, so we're fixing the macro call. And then exercise number 2. Yes, we don't need to do like what I did. We just need to put it further in code, because it's called by the compiler and should know it exists before it tries to call it. Pretty obvious, right? Okay, this one's good. This one's good. Number 3. Fix the compiler error without taking the macro definition out of this module. Okay, so we have a compiler error, and we need to like export it or something. So we can use macros, right? Or it still doesn't work. So we need to export it. That's what I tried to do the first time. It's not correct back then, but now it's what we have to do. And now we get an error. I see now. So if we export the macro, it's defined if the module is brought in scope. Oh, it is in scope now, right? I see now. Let's see the solution. I made another blunder. What? It isn't really explained there. But it's explained there. So little continuation of Daniel Keep's book, which has not been updated since the early summer of 2016. What else? Okay. So they show you how to write macros, and we probably should like, not we, but me. I should read it. Right? Maybe not right now, because I think it's gonna be just too much. It's not the issue then. Let's talk about Mars. That doesn't go really into detail and recommends this book. But this book was discontinued, right? So we have another version. Okay. Let's read the hint. In order to use a macro inside this module, you need to do something special to module to lead the macro out to its parent. Well, but the way I did it, like, it worked, right? The question is then, is it the correct way to do it? Take it without taking the macro definition out of this module. Well, also does work. Okay, I think we should just take macros later. I don't really care for them right now. It's kind of cool to see like how they kind of work. And so we need to fix the compiler error by adding 1 or 2 characters. One or 2 characters. Interesting. So where can we see this? Syntax extension. Don't need that. Relative macros. Yes. Practical. Okay. So we have practical one. We do have a practical introduction. Okay. How this works then? Too much explanation. So I kind of see how it works, to be honest. I'll do it in the sources they give us. I could just Google it, but also it can defeats the point. And I'm trying to think a bit. Oh yeah, so here it tells you how to have like multiple experience. So you do like this, and in this, and it works. Okay. Nice. And let's see. It's kind of obvious. Yes. I'm going to throw PP. And yes, we have like 8 of them, right? 8 of them. Okay, so Clippy. Clippy is like Clippy is tool is collection of lints. Okay, it's a linter or a collection of lints. Analyzer code. True. We need some code analyzing. Use the installation script or things. No, I didn't. I do have Clippy though. Okay. Not gonna read the doc, so, but let's just maybe try that. Clippy. Number 1. Collection of links. Okay, yes. This exercises the code will fail to compile when there are Clippy warnings. Okay, Clippy. What says that we should just use directly, right? Oh no, couldn't. Yeah, that we should do this. Doubt it now. Oh, I see. So it says that for like floats, kind of didn't get it, but we have like what constants. Maybe I'll do this like consts. What it says? A consts pi. We already have pi. It didn't work. Let me just associated type, like used like the radius, right? Okay. Maybe we should use like pi. Like this, yes. And like this, and this. Just bring the variable back, right? It's literally the type I'm using right now. No definition found. What? No definition. Okay, so it's std. I see. So probably what we should do. We should do something like use cd float 32 consts. Just get rid of this. Maybe do some spacing and just use it right here, and it's all good. Okay, we can check out the solutions to that. I mean, this is kind of like pointless, right? My version is better. We have other Clippy errors. The point is that checks right there, right? Do I have Clippy? Is this what like Clippy tells us? So for loop over an option, this is more readably written. If that, yeah, sure. For X in option, what we need to. Sorry. Why is it? Yeah. Or maybe like B flat. Some. True. This is exactly that. On to the next one. So many errors. Just one exercise. There's some more easy clippy fixes you can use. You can see it's utility. So you can see it's utility. Okay, fix all the clippy links. Sure. Add a comma, write the expiration in single line. So let's do this. How do we get less errors right now? It seems we don't, but we do get like a different ones. Now it tries to use the mem swap. Let's try to swap. Okay. What should we do? Should do like use cd what? cd mem replace. Okay. Where we should do this? We should do there. Okay. Put in a replace. Just give it a reference. Immutable references. Okay. Alright, how to do that? Mutable references. This and mutable reference to this. All good. But now make up a sure. What's the problem then? Return type of this goal. Like doesn't return something. Like we can just ignore it, right? Oh, I can't ignore it. Okay. What's the issue? Because what can we use like swap? Is there like a swap? Where is the swap? Should we use swap? Should we use replace? We should use that. Still got an error. Use the unwrap. None is none. So we should probably use relative. So says to us. Shouldn't use unwrap, but like what we should do. Remove the none and unwrap. Otherwise I'm just going to remove this. Unit value. Was it a unit value? Vector is empty after resize. How is it empty? Resize plus 70. think we should like check what resize does, obviously. Anyway, it's a function, so the create a vector. So what's the error? One previous error. It's unit value, so what's the problem? Maybe to once do this. After doing this, of course. And get better immediately. We still get an error. I can use clear. Let's see what the solutions say. I'm the same. Just print value. Or I did. Wrap an option, checking if it's none. Yeah. So we did all good, besides like unwrapping. Like app let some value, yes, equals to plugins. Yeah, I should have checked like that is not a part. Just missed it. By chance. What's around there? Can find value associated because it's just wow. Good. Never dealing with conversions. Nice stuff. Backcasting in Rust is done via the usage of the as operator. Note that the as operator isn't only used when typecasting. It also helps with renaming impers. Make a conversion before dividing. Good auto. Which is what? Use float 64 and there are like two sides. İşte bu da is right. Easy. So it takes precedence, it seems. I think it's still better to use it to make it more explicit. Next one is from inner. The from trade is used for value-to-value conversions. I see. So we have from trade. Implement the default trade to use it as a fallback when the provided string is not convertible into person object. So default and string isn't convertible person object. from string into person. Then we have default. Complete this from implementation to be able to parse a person out of a string in the form of like this. All that you need to parse the h component into. Okay. You split the string, which is pretty easy. Just gonna Google search for string. Find string. See what we can do. We can do split. Right. Can we like give it an amount of times to split? Split once. Okay. So we're calling as split once. And we give it a delimiter, which is just this. And it returns an option. Oh, it returns an option. And so, guess if the option is gonna fail. We're gonna do like let returns an option. I have two strings, right? Let if let sum. We have two strings. First one gonna be name, second one gonna be age. Equals this. We just match it. We're gonna go like this. If it's that. You're gonna do something, right? And otherwise, it's we do like return. Basic as whatever. I mean, like. What's how it works? How the whole traits work? I'm sorry. What's the issue? Create a function. How abstract, unstruct. Oh no, and let's watch again. Here. What do I do here? Missing. Oh, of course. We are trying to distract the tuple, right? So it wants a person. Once person. And we'll keep it a person. So we're trying to do what exactly? Trying to parse. And we can do parsing. I'm gonna call it like H. Like H, like SH maybe. Because what I'm gonna do next, I'm gonna do. Or maybe not. So we have a parse. I should like do mesh. Mesh. Like SH parse. Okay. And so what's gonna happen? We're gonna get either okay, and it will have H. We get H. and then return person name. Right. Like what? What's the issue there? Stretch for like, excuse me. Excuse me. August, Los Angeles. Another rather than nothing. But I can't do nothing when you do something. We get like this. And that. I was structure. I wanted default value, not default value. No? Is this how I do it? It's a match. Sorry. So variable name. Like clearly. And we failed a test. It's a missing name. It's a missing name. Okay. So yep, like how can you get it? Oof. Here's a better. Can we do it in a better way? Can we? Should we do that? I think what we could do is to like. We're checking. No, sure, no, default. This was kind of ugly. It's really kind of rusty, I would say. Okay, so how would I redo it? Maybe I'm gonna use like that. I'm gonna try to do this. Alright. I'm gonna try to do this. And by default, I'm gonna return like that. But then again, it's gonna be ugly, to be honest. Would be more concise. What do I do what? I'm gonna do like another method. Or not. I do like if let. So like okay, age, sh parse. With parsing. We parse. Then return like that. I also want to check like how did they implement it. Return that. But not before we check for what. So we can do this, right? And like name. It's like not empty or what? It's empty. What's the issue there? See. So we need to do another check. Results. Actually, after I use my brain cell for like half second there, realized that we should go back to that one. It was a better idea. It's a better idea. We should use this. This is also a better idea. Then we're gonna do that. Okay. Use a bunch of ifs. What are errors? We're gonna remove that. Also remove that. Okay. Then remove all that. This should be good, but it isn't. Why so? Do a match. We have a bunch of errors. Yes, I can see why. It's better now. So you may not return anything, which is bad idea. So we have something like a no return. Maybe I shouldn't have done it. You still have to return something. Can you have like a double check or something? You can create a person that. We should do like this. Just go back. Just go back, honestly. It was better. It was better. It was better, yes. It was a better idea. I'm gonna see like what they made. But this looks like a better idea. It's like it's correct. You can kind of understand like happens there. And we don't need to return. We don't need to return there. can try to use like magic expressions as much as I could. Yeah, just now I really want to see like solution to the like so it's from it, yes. Oh. I don't like that. My version is better. You can like do like split ones. This is better. Okay, next one. Similar to the previous exercise. Okay, and this is I guess this is actual exercise. Complete this from implementation to be able to parse a person out of string in the form of and the same part. We need to like parse person error, okay? Okay, I can see like where this is going. You know where this is going? This is going exactly into we're gonna destruct. We're gonna just start starting tuple. We're gonna get H. Oh, we're gonna get name. We'll get SH. Then we're gonna do this. We're gonna split it once. Yeah. Now the turns an option now. What to do? I need to replace there. Forgot how I do this. Let's see. So option. We have an option. We have an option. And I'm gonna try change an error if we can. Rob. So replace. Should here. Returns the provided default result. Not bad. Unwrap or replace. Can we replace this? I want to replace. Forgot. I think we had that. This is exercise. It was an option, right? Was somewhere here. Maybe here. No, it wasn't an option. It was in result. You have something like error handling, right? Map error. That's what we need. Mm. Hmm. Do map an error. Shouldn't do it right. Okay. So we need to do okay or and give it an error. No associated item named air found for. Sorry. Let me do something. Okay, let's do this. What do we do next? We're checking for A, right? Okay, how to do this? Oh, we need that. So return a self. I'll give it the name. Give it a name. Give it age. Return that. What's happened there? Parse this expression as a type. Okay, or like I don't get it. Give it a result. Give it an error. I don't get it. Or no. We just like, check for an error. Can we distract it like that? Like, just I don't get it. Here result. Like what's okay or S? Returns different result. Can we do this now? Okay, the front rate, whatever. Do it. Don't convert. Error parse. I don't get it. It's not found. It's right there. It's right there. Like right here. I'm sorry, but yes. Okay, so I'm stupid. I'm stupid, sorry. So with incorrect number of fields. I should have used this. Right. It's variant, not a module. What do you mean? Okay. Okay. We do this. Then we do okay or. Wrapper error. It's wrapper error. We need to get the error. We're gonna do this. Interesting. Oh, we can do this. We can no, we can do this. Map or we'll get map or it's an option. I need the option it result. No. I'm looking at an option, it result. So what I want to do? This. I want to do this. How do I do this? Scroll down. Do this. And the function cell. Separate. There's error to the new error. So we have our error. And we return then. Okay. The function mother. But if it's empty, the name. We return something. I'm going to return this. It's the issue now. Okay, we need to wrap it. We still got an error. Why do we get an error? It wants us to use an iterator. It wants us to use an iterator. Well, let's give it an iterator. Okay. Sure. So we get fields, right? Fields. And fields are what do we do with fields? We'll check for what strings believe let's give us. Just string. All that kind of string. With str. Yes. And then I need to do what? I need to check out this split function. Split pattern. We're going to collect. It's pattern, but it implements what? Yes. Yes. Okay. So. Let name equals to fields text. What's the issue here? Yeah, it's been readable. And also, if this happens, Okay. Then we go for H. Let H equals to fields. Next. This. Then if we have built, try to like parse it. Right. Try to parse it. Try to parse it. It's okay, right? Can't parse it. Can parse it. Very good. What do you think of that? So name, we have H. If for some reason, fields. Yep. So like for iterators. It was. Okay, check if it's empty. Iterator. Can you check if iterator is empty? And there is an easy way, right? We can just do next. If it's not. Turns up. The option is none. Is some. We select is some. Then we solve balance. Right. And if everything is okay, it's okay. Then everything is okay. Empty input. But like, we're checking for empty input. So no name, no bad name. But it did get us a next. But how is this even possible? So let's split. We should like actually like do still the same. Empty input. And I'm gonna check the test now. Good input, empty input. File name. Right, so okay. Like this can't happen. This can't happen. I'm trying to split like this. How is it even possible to split something? I'm sorry. What's the name even is? Okay, remember into like name is this. I don't see it actually. I don't see it print anything. Okay, it's empty. How? How's this? Oh, I kinda... No. Can't do this to me. Your end splits. But I don't need that to split inclusive. Returns and trader differs from the trader because a matched part, the determinator of this. I don't need this. With white space. By the white space, okay. Turns and trader sprayed by checkers, matched by pattern. Equivalent of split except that the trailing substring is skipped. We need that. We need that. Why this is so weird? Now we're failing again. How are we failing? How are we failing? Missing age? How? Okay. It should return D. It should return D. Like, what? What's the air split? Also, it does the reverse. Yeah, like splits is a little bit weird. You know, I don't want that. I don't want that. Okay, this is good, but like this is not good. Oh, don't need that. Okay, so this is inclusive. No, don't need inclusive. We only need once. We need this. I'm sorry. To get the name. Wait. Maybe we should use this background. Oh, the name is good. Miss an age. Try the trailing comma. 2 failures. Okay. What we got there? Got a tone and age of 32 somehow. Why? We're missing an age. Okay. Parse integer. What we get? Okay, so we get by length now. It's because it's I mean, I think we should do just use like regular split, like, so the iterator, if it has a like an average string here, length is there like no name. Okay, let's try. Let's try to check. This feels kind of weird. Okay. We could like check for this, but why it works like this? Should be 0. Why is it 0? Why is it 0? How does this even works? Will this work now? Okay, we can just use that, and it's gonna work apparently. But I want to see the solution. This was so weird. But right now, this actually feels solid, right? I see. Yeah. That version is better. Like, I see why they did this. Yes, we can just like do this, like check. I could try in their pattern, but this will like, you should just copy and like rewrite it. So just kind of to remember what happened. Good name. We have an age. We have this, right? It's gonna be with E flat. What if not? How did they do this? Okay, so we can. This is really interesting. We can do it like this, basically. take a better imagination. First we get like fields. Goes to like this, and you split it. And then we're trying to get our next. And next. And next. And else, just gonna turn that. So we're up. What do we need? Let me check if name is empty. Over the village, we parse it. Like this. This is more clean. Try from the simple and safe type conversion that may fail in a controlled way under some circumstances. Basically, this is the same as from. Should return a result instead of target type itself. Okay. So why can't it fail? What kind of health do we have? We have 2 vials. Tuple can have an incorrect rank, right? But can fail to convert the colors. This can happen. So we'll try to return what? I should return like south, obviously. Has green, has red, and has blue. Right? Just not an error. Think like this. Don't care what like happens there, but just give it a. Just give it. Smash types. subscalar and should drum that. Saw the issue. Expected. Okay, return. Try to return. Okay, right. It's a primitive type. That have fields. True, but should have tried it over than that. Still fails to me. I'm sorry. I-16 is a primitive type. I mean it is, but I can parse the string. Oh, okay, so it's not a string. You can parse it. This will give us an overflow. If we must check something. Let's check. Or inside integers have. They like do some convert whatever. Trying. Just do that actually. Okay. I found a result. This is too early. I see. So we need to. Yes. What changed? Like, it should be error everywhere. This is really inconsistent. Maybe that's the goal. Who knows? Who knows? This is an array implementation. You basically would do the same, right? Sorry. So do we have like lambdas in a... Look on the bottom. What we could do is we could maybe let's enter this right now. Okay. So we already checked if it has like 3 elements. Representation. correct length. So here we have a slice. Okay, we have a slice. I think we should like the canary implementation. It's basically the same. Just copy that here. But now it's like easy to make it a little more pretty. I mean, we could have a helper function. Let's see really point to do this right now. Probably get length of the slice. Maybe should be silent. No size. No fill size. Slice. The slice. Okay. Does the slice have a length? I think it has this. Then it's gonna be 3. That's so good. What's happening? Get this. Otherwise, you can get an error. You gotta get an error. And we got an error. Oh, let's see. What kind of errors do we have? We have a bad length. Okay. So this is the error we're gonna send. Not bad, it's bad. Top braces. Too often. Okay. Let's see the solution. Oof. This is I will say it. Okay, so we can just use yeah. I'm gonna write that because right now we can do it like this. But yes, let's do the final one. Or like prayer final one. Okay. For cheap reference to reference conversions. Reference to reference conversions. 10 the number of bytes. not characters, and they give an argument. And they give us a link right there. It gives us a reference to our argument of type T. Like, what's the issue there? Like what? Or once. Once type. It has type. Right here. Yeah, type. Font for type. Spawned by the like how you do like it's a T, but it's not just T, but it's like you should like go to traits. Maybe this one, maybe like okay. But that is just implement a trait, it's also T. How can we a T that implements trait? Okay, so you can run on it. We can do this. OLED. Okay. Or the reference. The reference gives us type. What types do we have? Of this type. So this should be like what is gonna implement no, it's straight, so it's like okay, so this is T and he's gonna do okay. No method name as bytes found for the reference T in the current scope. Spawned by the tray, a query. Spawned by the tray. Search for like adds bytes. What we have? We have OS string extended, and it's like we have like Unix like this. So okay. I think like do like this or something. Or what? I forgot how to do this. Oh, just like plus sign. Okay. Isn't this like the solution, by the way? This is so weird. Feels like I'm doing something I shouldn't be doing. to be honest. Like we have like is ref, we have like is mutable. It's so what did I didn't actually read me. Read me file. So we can read it. It's in the, card in where? I'll get an edition. Excuse me. That's a string. The tray bar. I literally don't get. I do it like this, like. Wait. Number of carriers, not bytes. Get a car counter. Well, he's like just like the same. Squares. Property tray bound. Also implemented a function body. Okay. So got errors. We need to run a square. Okay. Why would we need reference there? Oh yeah, because we want to multiply it. So this is a reference. They want to set it. So something like this. But then we need to like mutable. Procedure. So as ref, okay. I can't mouse your notes button. Why do we need a reference even? Oh, so we can. Why does it have to be like this hard? Is like the compiler even trying to help me? Why does it make my life harder? Just skip. Can't multiply. Like I just want to multiply stuff. It's an as mutable. How? Squares, numbers. Feel so dumb right now. Let me just so we have an argument, right? Can we just do like n equals like this column, right? So this is the clone. But maybe don't have a clone. Okay. That doesn't have a clone. But don't clone this. Can't use this. This is immutable. Can't enter the expression. I don't get it. Just done. Why could you use it like this? That doesn't make any sense. Makes zero sense. Why would you write it like this? Then just like set it like this. We have a reference, we can just set it. Can I get like okay? Can I dereference it? I don't get it. Oh, we do something like this. Do it like this. Does it work? Taskwork. No way. No way. Is this like even the correct answer? Algorithm. Solution. Okay. I got that one right. I kind of feel like this is kind of cheap way to do it, honestly. Quite nice. Makes zero fucking sense. Makes zero sense. Whatever. We've finished it. Okay. We did it. Finished rustlings. It was good, but I kind of liked the previous conversion exercises, but this one feels kind of. I mean, Rust is hard, yes. You can like put everything into nice exercises. Still, this was kind of like not really explained well, and like, what's this? But I kind of get the point, but whatever. Thank you for watching, and I'll see you in the next video.